Thank you. I hope you enjoyed lunch. Welcome back. I have just a couple of housekeeping notes before we get started. It turns out we have another first for the developer conference. You have exhausted the final set of IPv4 addresses. No, we have a limited number of IP addresses in the room, and so if you can sort of limit your use to one device per person for a while, that would be helpful, so thank you. A number of people have asked when the videos will be available and when the presentations will be available. Both will be linked from the conference site. The video will be available in one format tonight and then broken into smaller pieces tomorrow, so the video will be up very soon. The presentations, probably over the next week or so, we'll have them all linked from the site. Lastly, we don't have a feedback form up just yet. We're working on that. Please do start thinking about your satisfaction with the day as a whole and the individual sessions, and we'll send you the link, and it will, again, be linked from the site later today. So to lead off the afternoon, I'd like to welcome Arvind Jain, a Google Director of Engineering, to give a talk on web performance. He's also co-chair of the Web Performance Working Group. Thank you very much, and welcome, Arvind.
Thank you, Ian. My name is Arvind Jain. I work on Google. I work at Google in web performance. Today, I'm going to talk about a few new performance APIs designed to help improve the performance of the web. This work is all part of the W3C Performance Working Group, of which I'm a member of. We created this working group last year. Our mission is to build web standards to help make web pages fast. So the first thing that I'm going to talk about is the web timing APIs. It's sort of important. To actually make the web fast, you first need to measure it, and that's actually a pretty difficult problem. Before the web timing API, we didn't have mechanisms in place to actually allow developers to see how fast their web pages are in the real world. So that's what the web timing API does. It allows web pages to get detailed information about how much time does it take to load. A developer should have access to this information from any browser or device, be it mobile or desktop. And the browsers should provide a consistent interface and also consistent metric definitions, so that as a developer, you don't have to worry about instrumenting your web pages with different timing code on different browsers. It's also very important to provide a lot of detailed information about timing. The information could be at the network layer or the HTTP level or at the DOM level. All of those informations are actually fairly important for a web developer to actually find out what is wrong with the page, where is it actually slow, and what can the developer do to actually make the page fast. The web timing API is actually consists of 4 different specifications. The first one is navigation timing, resource timing, user timing, and performance timeline. All these 4 combined sort of give you a fairly detailed picture of what happens as a page gets loaded, what element takes how much time to load. So I'm going to cover all of these 4 APIs today, and also discuss the status of implementation as well as specification, and finally talk about some real-world use cases of these APIs. So the first one is navigation timing API. This provides timing information related to the main page as it is loaded. It's actually a fairly simple API. It has 2 different interfaces. The first one is window.performance.timing. This allows a developer to actually see timing attributes at network level, HTTP level, and DOM level. And then the second API is window.performance.navigation, and it tells you how the page was loaded. Was it actually a normal navigation, or did the browser actually, did the user reload the page, or actually went back or forward in his browser history to load the page, which is sort of important because timing, generally, the timing of page loads, depending on whether it's a normal load versus a reload or a back forward, is very different. So these two APIs combined gives the web developer fairly detailed stats, as far as what is happening when the page gets loaded. This is a reference figure which shows you what are all the things that happen when a page gets loaded. As you can see, there are network level attributes here. For example, how much time does it take to do a domain name lookup, or how much time does it take to actually do a TCP connect to the website from where the page is being loaded. And there are also quite a few DOM events as well. For example, DOM loading, or when is the DOM actually complete, DOM is complete. And then finally, it also includes the total load time of how long does the page actually take to load. This is the actual interface, the performance timing interface, which shows all the different time values that are available to a developer with navigation timing. So with navigation timing, it's actually now possible to get a complete picture of how long does a page take to load. Earlier also, you could actually do some instrumentation, but you had to actually do it yourself, and you could only start instrumenting a page once your code starts to execute. With navigation timing, that's not the case. So now you actually you can capture the time from when the user actually clicks on a web page to all the way to when the page is loaded. So you get this complete and more accurate time of what is the user perceived latency. Navigation timing is actually supported in IE9, Chrome, Firefox, and Android, and more browser support will come shortly. With respect to the specification, we are targeting moving it to PR stage later this month. So navigation timing provides insight into different components of overall page load time, but it's still not fine-grained enough. And which is sort of easy to see because a typical web page is made up of more than 50 individual resources. There are quite a few sites out there which actually publish these stats, one of them being httparchive.org. So a web page in general is very complicated, and it consists of tons of individual resources, and often most of the time spent in loading the page actually comes from loading all those individual resources. So that's where our second API comes into the picture. The resource timing API provides timing information related to individual resources on a web page. For example, images or scripts or objects, iframes, SVG, etc. This API is also pretty simple. For every resource on a page, a performance resource timing object is provided. And this object contains information about various network and HTTP level timing attributes for that particular resource. For example, how much time did it take to connect to the server that hosts that resource, to how long did it take to actually fully download that resource. There's also another interface called window.performance.getEntriesByType. This particular method allows you to get the performance resource timing objects for all the resources on the page. So these two methods combined gives the developer the ability to get timing information for every single resource on their page. This is the actual interface with all the different attributes available. As I mentioned, the attributes include network level stats, like how long does it take to do a DNS lookup, how long does it take to actually establish a TCP connection, do an SSL handshake, and then of course, how long does it actually take to download the resource from the server. There's also one interesting attribute which I'd like to talk a little bit more about. That's the redirect and then redirect start. So sometimes these HTTP resources are not available from the server right away, and there's a chain of redirects before you can actually get to the final resource. So if this resource is on the same origin as the host page, then you can also get the time it took to actually go through all of those redirects before you could download the resource. So resource timing provides insights into time spent on individual resources on the page, but that's also not complete as far as the needs of developers go. Often the developers need the ability to understand the performance characteristics of logical components of their application, which don't necessarily correspond to HTTP level resources. That's where our third specification comes into the play. It's called user timing. And essentially what this interface does is provides a high precision timer value across all the user agents to the web developer, and also a standard mechanism for buffering and retrieving timing information that the developer of the page himself provides to the browser. The API again is actually quite simple. It provides a way for a developer to add a timing mark. A mark is essentially just a name and a timing value, which the browser will then buffer for you and make it available for you to retrieve later. And there's another method called measure, which is essentially a duration. And typically, a developer can measure a time between two different marks or between the current time and a mark that he previously created. So this is just a standard way of buffering and retrieving timing information across all the different browsers. The last timing specification is called performance timeline. This is actually just a wrapper around the three different timing APIs that I just described. So you can access the navigation timing API, the resource timing API, and the user timing API all through the single interface, which is available on window.performance object. And these are the three different methods that are supported there. For a given web page, you can actually just call window.performance.getEntries to actually get all the timing objects associated with this page. So this would be the navigation timing object, as well as all the resource timing object for all the resources on the page, and any user timings that you actually created as part of your application. All of these stats, so navigation timing, as I discussed, is already implemented in the major browsers. These resource timing and user timing, as well as the performance timeline implementations are not yet there, but we expect both IE and Chrome to implement that by March of next year. And accordingly, we are hoping to move these specifications all together to proposed recommendation stage in March 2012. Now I'll talk about a few security and privacy issues that we faced while we were developing these interfaces. The first issue is with respect to cross-origin access. So in general, we enforce the same origin policy, so we don't leak timing stats across domains. But with resource timing, we allow a web server to actually send a header back to the browser to make its resource timing object available cross-domain to the page. Another issue that came up while designing these APIs was that now it actually becomes easier for someone to detect whether a user is behind a proxy server, because typically proxy servers are fairly close to the users. So and also they proxy all TCP traffic. So now that you have connection times available to all the hosts in the world, you can actually deduce whether a user is behind a proxy or not by just checking whether all the TCP connect times are sort of similar and of low value. That's a real concern, and it's not really feasible to mitigate this attack from the browser. But our discussions basically ended with thinking about that this is not a sufficiently big problem to actually outweigh the benefits that the timing APIs provide. So we sort of left it there. It's an exposure, but we're willing to sort of live with it. The third attack is fingerprinting attack. So again, a concern was brought up. We said that there's a wealth of information now available to developers around timing, and that could further be used to actually identify individual users. But then the security, we got a security review for this, and it turned out that there's actually very little added value from timing stats to the existing attack mechanisms. So again, this is something that was brought up, but people are okay with with actually having the API in place without worrying about the fingerprinting attack. The web timing API is actually in use now in the real world. These are just a few examples. This list is by no means complete. This is what I could actually find on the web myself. All of these are actually performance measurement tools. These tools allow developers to find out how fast their applications are in lab setting or in the real world. And all these tools have upgraded themselves to using the web timing API to actually provide those timing information in a more accurate fashion. Specifically, with Google Analytics, actually, I do have a screenshot. This is what the site speed report looks like in Google Analytics. So any publisher, web publisher that is using Google Analytics now get this site speed report without doing any work on their own. So if any one of you have a website and you use Google Analytics, then you can go right now and check how fast your site is in the real world. And you can do the normal drill downs on it. You can see if your page is slow for a particular browser or for a particular region. You can also see the different components of your page load time. For example, whether it's the DNS for your website is too slow, or whether TCP connecting is too slow, or the page load is too slow. And you can sort of look at all these different metrics and then figure out what is it that you really need to do to actually make your site faster. All right, so that's all about timing. The other thing that I wanted to talk about today is page visibility. This is a new API that allows web pages to determine the current visibility of a page and also be notified of visibility changes as they happen. This is, sometimes people ask me, why is this a performance API? And there's quite a few interesting use cases for a page visibility API. These days, especially many web applications are actually quite active, and they do a lot of processing or work all the time. But if they knew that the application is actually not being used by the user, or it's not even visible to the user, they could scale back work, which would actually make room for the actual foreground activity that the user is involved with, have more resources available to it. Or it's just generally a good thing to do to, for example, conserve battery life on mobile devices. So the visibility API allows you to do that. You can see when your application becomes hidden and is no longer visible to the user. And whenever that happens, you can take the decision to scale down work. There's also a side use case that we discovered when we were actually coming up with this specification, which is implementing analytics accurately. So there are quite a few web analytics tools out there that measure things like how much time did the user spend on a page. And really, all those metrics were not accurate because it was not possible for a developer to actually know whether the user is actually spending time on the page or not, whether the page is even visible or not. So this API helps developers make these kind of metrics more accurate. So this API actually looks pretty simple again. It's implemented on the document object. There are two attributes. There's a Boolean attribute called hidden, which obviously returns true when the page is not visible, and otherwise it will return false. And there's also a attribute called visibility state, which provides a little bit more information with respect to the state of the page. A page could be hidden or visible, but there are a few more states that are relevant to different browsers. For example, some browsers have this mode called preview, where they're showing a page, but it's actually in a very small preview window. Chrome has this mode where it can have a page loaded but completely hidden from the user. That mode is called pre-rendering. So the browsers can actually put in more information in the visibility state to exactly tell the developer what state a page is in. In addition to these two attributes, there is also a visibility change event that you can register using a add event listener. And that callback gets called whenever the document changes visibility. So the status of page visibility is it's supported in IE and Chrome right now. Firefox is also working on the implementation of page visibility, but we're still ironing out some issues before we can have the support in Firefox. With respect to timeline, we are hoping to take it to CR next month. Here are a few real-world use cases of page visibility. Google Analytics uses it to do impression counting properly, as I just explained before. If a page is never shown to a user, for example, if the page was pre-rendered by Chrome, then Google Analytics will not count it as a page view and won't break all the stats that their publishers are used to seeing. YUI has this idle timer implementation that is now based on page visibility. And Google.com also uses page visibility in an interesting way. Google, when you do a search on Google, it will tell the browser sometimes that the browser should preload the first result. It does that when it can predict that the user is very likely to click on that page. So Google search does that whenever the queries have high prediction rate, and it can we know that the user is actually going to click on those results, and the browsers actually go ahead and preload those pages in a hidden tab. The reason for doing that is to actually get this get the page loaded before the user actually makes that click. So there's often users actually take a few seconds before they click on a result. So the page is sort of getting a head start, and it can start loading, and by the time the user clicks on the page, it's instant. It can be made instantly visible to the user. So this is being done on Google, but it results in this problem of what if the user actually did not click on that result that Google thought they would click on. So in those cases, the publishers can actually use page visibility API and determine that this is actually a case of Chrome pre-rendering a page, and the page was actually never made visible to the user, and they can run their analytics and they can compute their metrics accordingly and not include this page, for example, in their page views. So these are just a few examples of how we're using page visibility to actually build applications which make the web faster. That's really all that I have. We have quite a bit of time left for questions, if there are any. So I'll be happy to take those.
My name is Ni, and I'm a software engineer from Disney. And I have a question. Well, it's not very related to your topic, but it's related to Google. So we are building HTML5 secure live video streaming solution for Disney's affiliate company, ESPN. And we adopt Apple's HLS live streaming standard. Well, it works pretty well, but when it comes to Android, well, there's no such thing. And I'm kind of interested in Google's take on HTML5 live streaming. And this is also an open question for all browser vendors. Thank you.
Yeah, well, as you said, I mean, this is something that I don't actually work on. So I'm not able to comment on Google's position on Apple live streaming. I mean, personally, I feel it's a pretty good standard, and I mean, I would like to see all browsers implemented, because it's sort of it's very intuitive. It's and it has all the elements of actually making live streaming work in a nice way across different user agents. Thank you.
Paul Cotton, Microsoft, and co-chair of the HTML working group at W3C. So last 2 weeks ago at the W3C technical plenary, when the HTML working group met, we actually met in a joint session with the web and TV interest group at the W3C and made a lot of progress on talking about making sure that various aspects of video work really much better than they're currently spec'd in HTML5. I'm sitting right over here at the back. I'll be here all day today and tomorrow. And if anybody wants any more information, I can point you to the public minutes and the public notes from those meetings.
Thank you.
Yeah, Rick Ells from the University of Washington. Anytime I see nice numbers, lots of numbers about user experience, I wonder if this could be sort of usability testing, improving the user experience as a whole. Do you know of anybody who's using it for that kind of research?
Yeah, absolutely. Well, that is actually one of the main reasons for making all of this timing data available, is to actually help developers figure out, what is it, that actually, takes a lot of time and therefore, maybe actually hurting, the end user experience. So there are a few things, that people, that at Google, for example, we do with these metrics. The very first thing that we do is, if we see some particular element on a page take too much time to load, that's obviously a performance problem that we need to fix, because our goal is to make sure that pages load instantly all the time. So that's basic performance analysis, right? The user timing spec actually allows you to measure other interesting things. For example, if you have one of the things that we measure for Google search, for example, is how long does it take for a user to click on a result. And that's actually a very good metric for us to actually determine whether we are actually providing the right set of results to our users. So absolutely, there are, I don't think there's any dearth of examples of how people use, these different timing metrics to actually make their products better. Yeah. Hi.
Yes, could you address the issue of whether you would encourage using image bundles or stay with individual images as far as the resources on a page?
Right. It's sort of, with the performance testing that we have done, the more the number of resources on a page, often, turns out that the slower the page gets. So there is, these days, for many properties in Google, and I know that many people do this outside of Google as well, there is this tendency to actually bundle together objects so that you actually make only one request and you can get all the responses back. So that strategy actually works most of the time. Certainly works even better in the mobile area. So, but it sort of depends on what kind of images are you talking about. I mean, if you're talking about lots of large images which are actually very cacheable, then bundling them may actually not be a good idea. On the other hand, if you're talking about images which are rarely cacheable and are sort of small, then it sort of actually makes sense to bundle them because you don't really care about their cacheability anymore. So it's sort of, I think it really depends on your use case, whether bundling would actually help you or not. One thing that we want to do though is actually get rid of that problem from a developer's mind. Like, hopefully you didn't have to do anything. That's what we need to provide from an infrastructure level. So an example of that is the Speedy protocol, which Google has been working on along with a few other industry players. In that protocol, you no longer have to pay the penalty of issuing multiple requests to download multiple resources, because you can do them all in parallel and you can get the responses back in parallel as well, all multiplexed. So hopefully, in the future, this question would sort of become irrelevant, with better application layer and transport layer protocol. But for now, it sort of depends, on your use case, whether bundling would help or not.
My name is Ben, and I work for the University of Washington as well. And I had two questions. One is about whether these APIs have considered any use for situations where you'd be using a comment-like interface, where you have a persistent connection that stays open. And the other question is about a bullet point you had on, we didn't talk a lot about, which is falsifying some of the timing attributes. And how has the working group looked at addressing those things?
Right. So if you look at navigation timing, that sort of doesn't make so much sense anymore when you talk about a comment-like scenario, or where you're sort of constantly downloading a stream of bytes from a server and doing something with it. Because navigation timing is sort of more relevant to a typical page load, like you go to a web page and the response comes back and you're done. But if you look at the other two APIs, resource timing and user timing, those are very much designed to actually help you measure performance of applications like the one that you suggest. So if you have an application which is sort of always on, it never really stops, you're sort of still interested in finding out the timing attributes of small logical events within that application of yours, then you can use user timing or resource timing. So yes, we did talk a lot about scenarios like these where we're no longer talking about a web page, and really what we're talking about is a web application which is long running, and these APIs are supposed to help you out there. With respect to tampering with the metrics, I mean, it's an interesting question. I mean, I think most of the times these metrics are actually for the page developer, so it's really you are the one who's actually making use of these metrics, so it doesn't really help you in terms of tampering it. It's actually, I guess the issue becomes more relevant when somebody else is actually going to make use of that timing information to do something that you may not like. So I think in those use cases, I mean, yes, there is this problem of that. For example, a publisher could modify the window.performance object and just put his own object with really nice fast timings in that object, and then Google Analytics will take that and upload that into their backend. But again, even in that case, Google Analytics data is actually for the publisher and nobody else. So I think the concern of tampering with with the statistics is actually not that high.
Charles from Opera. So sort of following on from that, and from some other stuff you said, we looked at the fingerprinting aspects, and you looked at the tracking aspects, and we make maybe a lot of decisions which we're not really opening up the attack surface very much. We're not actually making a big new attack possible. You could probably do most of it anyway. At what point do we get to the You know, by 1,000 slices of nothing really serious, we just blew a huge security hole.
Right. That's a very good question. It's also hard to answer. I mean, I think really you have to look at every individual threat that we are exposing and make a conscious decision. So in our case, for example, the issue of providing a bit more information about a user by having these timing measurements available does add to that a already very large list of metrics available for somebody to launch a fingerprinting attack. So in this particular case, we didn't actually feel that there was a sufficiently non-trivial amount of information that was being added for that particular attack. But in general, that's a good question. I don't know. I mean, clearly, I think we're very good security people in general, in the industry, and normally, our approach, at least in this working group, is to actually really defer to them, when we make decisions like these, and that's what we did, with respect to these particular attacks. All right, seems like that's all. I mean, there are no more questions. Thank you again for coming.